In the first lab, you learned that motion, including average speed, can be modeled using a distance versus time graph. In this lab, you'll practice calculating average speed and then adding to that average speed a direction to indicate velocity.
Read the introductory paragraphs paying attention to the difference between average speed and velocity and the definition of acceleration. Turn to slide 2 and complete the Before You Begin activity. Now read the introduction to part 1, noting the definition of average speed. This is a diagram of the lab setup.
Here you see the setup in the classroom. The car is held at the top of the ramp and released. The timer starts as the front of the car reaches the bottom of the ramp and then is stopped when the front of the car passes the 5-meter mark.
Turn to slide 4. This is the data table with all 3 trials and the mean filled in. The first trial was 3.1 seconds, as was the second, and the third was 3.3. You should type these numbers into your data table. Go on to the data analysis section. You have already calculated the mean. Question number 2 tells you to use the formula S equals D over T to calculate the truck's speed. D, distance, is 5.0 meters, and the time is the average time for your 3 trials.
Finish the remaining questions on slide 4 and go on to slide 5.
Read the introduction to part 2. Be very conscious of the fact that a change in either speed or direction, because they are both components of velocity, will result in acceleration as we define it in science. This is the diagram of the setup for part 2. The only difference is that this time, timers are positioned at each of the meter marks so that the time it takes the truck to travel 1, 2, 3, 4, and 5 meters can all be recorded for each trial.
All 5 timers start their watches when the nose of the car reaches the first blue mark at the bottom of the ramp. Then, the timer at the 1-meter mark stops her watch when the nose passes that 1-meter mark. The timer at the 2-meter mark stops her watch when the nose passes the 2-meter mark, and so on. 4 trials are taken, and the average of the time at each meter mark is calculated.
Here is the data for you to copy into your data table on slide 6. The mean time at each meter marker is calculated. I've done the average for the 1-meter marker. Now use the S equals D over T to calculate the average speed of the truck during the first meter by using D equals 1.0 and T equals 0.19 seconds. The result is 4.35 meters over seconds. Record this in the last box of the first row.
Calculate the remaining speeds using the average times you calculate from the 4 trials at each meter mark and using that distance. Then complete the final column of the data table.
Look at the bottom of slide 6. You will create a graph of distance, 1, 2, 3, 4, and 5 meters, versus average speed at each of those distances. Decide which of the 2 values is the IV and should therefore go on the x-axis. Then determine the type of graph you should make. Now open the Google Sheets document that goes with this lab in Google Classroom and enter your average speeds from the final column of the data table on slide 6. Highlight the data table in Sheets and click on the Chart button highlighted in yellow and select the appropriate graph type.
Copy and paste your graph into slide 7 and then finish the questions through slide 11.